Hello, and welcome to the next video in the mold design series. In this video we will focus on the parting surface part feature of Cimatron mold design. This works hand in hand with the quick split function to establish the necessary parting surfaces to create our mold core and cavity parting surfaces. In this video we will cover creating internal surfaces, creating external surfaces, runout, and constructing corner locks. We will be using the part we split in the previous video in this series. So if you haven't already, we recommend you watch that first. So, using the part we split in the last video, we will choose a direction, or a set of faces, to create the parting line. Once we have established our part direction and have all the faces assigned, we will begin creating the parting line surfaces. It's not uncommon to use multiple sets of faces to do this. In fact, when working with mechanisms, it's necessary to use many sets. We will start with the faces assigned to the core side and turn off all the other face sets. First we must create the internal seal-offs. We can use many functions to make these individually, but in Cimatron, we have a function that will create most, if not all of these all at once. We are working with a closed solid, so we'll use the cap internal islands function. We will need to select the area we would like the system to analyze for internal openings. In this case, we will select the entire part. There are a few options in this function. They can be accessed through the drop-down menu item here. All these options are fully explained in help files embedded in your copy of Cimatron. The system will show us all the islands it has found. We can then apply these options and let the system develop the surfaces it can. The result is all the internal islands were capped or filled in. We will perform a quick check of all the other faces to view our progress. Looking at the geometry, we can use this horizontal feature to start developing the outside seal-off surfaces because this edge is consistent all along most of this part. To do this, we will create a composite curve to develop the surface. Using the Along Open Edge option, we can create this composite by selecting the first and last edge we want to follow. First select the edge starting just outside the U-shaped feature. Then select the edge just before the Side tab feature. Applying it creates a composite curve along these edges. We can then create composite curves along the back and the other side of the part the same way. Open the composite curve feature. Select the first and last edges to use to create the composite curve. And apply. Repeat for the final curve. With these composites created, we are ready to create our seal-off surfaces. From the face tools, we'll extend the surface from the part edge. By using the tangent option and setting the delta, we can develop a surface. We also have the option to create this surface as multiple faces or a single face. Create the other faces the same way. Extend the surfaces from the part edge and click OK to finish. Now we'll look at the two areas on the sides. Using the same method as we used on the other edges, we'll create a composite curve in these areas by selecting the first and last edge. We can now use the blend function. Select the first edge of the extended faces and right-click to open the blend tool. Select the second edge. In this function, we can pick a boundary curve and have the blend surface follow it. We also have the option to make the two defining edges be tangent to the adjacent edges. This would create a much more tolerant surface. You can see the smooth surface. And we must do the same with the other side. Right-click and select Composite Curve. Pick the first edge and the last edge, and create a composite curve. Then add a blend and set the tangent values. We can now look at developing the surface in this U-shaped feature. There are many face functions we could use to fill this area. There are many curved edges and contour changes here. First, we'll create a spline from the two extended faces to match the contour. Then we will create another composite curve to make a boundary, using this bounded face function. The preview shows we didn't quite get the correct result. Cimatron has a very useful function to develop surfaces in these areas. It's called warp faces. We can still use a composite curve with this warp face function, but first we'll have to create a face to warp. Using the Sketcher feature, make a sketch and a flat surface on the XY plane. Use the bounded function to make that surface on the XY plane, so the new surface is below the area we want to warp up to. With the surface now I can use the warp face function. First select the face to warp. Then select the boundary or composite that defines the area to fill in. Check the direction arrow points towards the area to be filled. And when you are happy with your selection, click OK. We now have a much better surface in this area. It follows the contours much more smoothly and consistently. The mold-making capabilities within Cimatron are making light work of the tasks. With all the seal-off areas addressed, we can now create the run-out surfaces. We'll make a new composite curve along the entire outside edge of the seal-off area. Using the extend function again, we can make a nice run-out surface. Give it a dimension to make sure there is sufficient surface to extend past the core and cavity block edges. This can be edited later if need be. This mold requires corner locks. We can do this by adding a component to the assembly. Using the Add Component option from the Assembly feature, select the corner locks to add. The corner lock component will also be added to the setup table, allowing control of parameters like the spacing of the locks, their length, height and width. We discussed the setup table in another video. The locks are placed on the main assembly UCS. Select the option here. With the quick split surfaces, we now have all we need to create the core and cavity blocks for this mold. This concludes the parting surface part portion of the mold design tools available from Cimatron. I hope you have found this informative, and you will look for our next video in the mold design series named Setup Table. Thank you for watching.